Assalamualaikum and greetings to everyone. My name is Muhammad Danish Fidaus and I am from UiTM Perak Kampus Tapah. In this video, I will be explaining about electron configuration using three principles. There is Aufbau principle, Hans rule, and Pauli exclusion. Without further ado, let's go. So basically, electron configuration is the electron arrangement among the various atomic orbital. And before we start into the principle, we have to know how to write it. For example, in this case, 1s1. The first one is the principal quantum number. Basically, this is the shell for the electron. The other one is the number of electron in the orbital. And the S is the angular momentum quantum number. I will be explaining about the SPDF later. And without further ado, let's go into the first principle. Aufbau principle. Aufbau principle is a scheme used to reproduce the electron configuration of the ground states of atoms by successively filling subshell with electrons in a specific order. Fill up electrons in lowest energy orbital first correspond to the increasing energy of the subshell. So basically, Aufbau principle is an electron configuration that is right from the lowest energy orbital to the highest energy orbital. For example, like this. In this drawing, you can see the pattern that is being used. The first row, it uses the angular momentum quantum S. The second use P, and the third use D. And from the side, it has the first row use one shell, the second use two shell, three shell, and so on. The 1s has the lowest energy orbital, while the 6s has the highest energy orbital. This chart is used like this, from 1s to 2s, 2s to 2p, 2p to 3s, and to 3p. But it's not going to 3d first, it's going to 4s first, 4s and to 3d, and so on. It should be like this: 1s to 2s, 2p, 3s, 4s, and so on. But remember, S will always has the maximum of 2 electron, P has 6 electron, T has 10 electron, while F has the maximum of 14 electron. We move on to the next principle, that is Hans rule. Hans rule states that every orbital in a sublevel is singly occupied before any orbital is doubly occupied. We're going to take one example, nitrogen. Nitrogen has 7 electrons, and from the Aufbau principle, it's written like this. This is the electron, so S it has the maximum of 2 electron. 2 plus 2 is 4.
2 plus 2 is 4. Minus 1, that's 3. Quick maths.
2 plus 2, 4, and plus 3 equal to 7. So nitrogen, the Aufbau principle is written like 1s2, 2s2, 2p3. And from this Aufbau principle, it can convert into Hans rule like this. Hans rule states that every orbital in sublevel is singly occupied first, before any orbital is doubly occupied. Like this. It should be single orbital first, before doubly occupied. It cannot be written like this, double single. Hans rule said that you should singly occupy first before double. So you should take this one to here like this. And from this principle, there exists another principle, that is Pauli exclusion. Pauli exclusion principle states that no two electrons in the same atom can have identical set of quantum number. We take the example from the Hans rule. The two electrons must not have identical set of quantum number like this. The electron must have different spin. To conclude the lesson, we're going to do one last example. Let's take magnesium. Magnesium has 12 electrons, and the first we have to use alpha principle. Let's take note, S will have a maximum of 2 electrons, P 6 electrons, T 10 electrons, F 14 electrons. So using the alpha principle, it should be written like this: 1s, 2s, 2p. S has the maximum of 2 electrons, 2 plus 2, 4. P has the maximum of 6 electrons, 6p, 10. Magnesium has 12 electrons, so it should plus 2 more. And according to alpha principle, after 2p, it should be 3s. And we need 2 more. This is the alpha principle. Next is the Hans rule. 1s, 2s. P has 3 sub-label and S has only 1. So according to the Hans rule, you should write the singly occupied first. This is only 1 sub-level, then it should write the secondly occupied like this. And for the 2p, single occupied first, and 6 the second occupied. So 1, 2, 3, 4, 5, 6. 6 electron, and for the 3s, 2 electron, single occupied, secondly occupied. This is the Hans rule. And from this Hans rule, it should be exist Pauli exclusion. That's all for me for this video. I hope you guys understand the explanation. Have a great day, and I hope see you next time.